In this example, we are going to solve the inequality. It's already been factored for you. So you're just going to go right into setting each factor equal to 0, and then you're going to make a table of values to find your positives and your negatives. So if you set 2x plus 1 equal to 0, you're going to subtract 1 and divide by 2, which is going to give you negative 1/2. If you set x minus 1 equal to 0, you're going to add 1 to the other side and get 1. If you set x equal to 0, you get 0. And if you set x squared minus 1 equal to 0, you would add 1, and then you would take the square root, and then you would get plus or minus 1. When you look at rational expressions like this, where you have a denominator, you can never have 0 in the denominator. So whatever x values you get in the denominator, those you need to make sure you change to not equals. So we cannot have x's that equal 0 or plus or minus 1. Then if you look at the factors that you got on top, so we got negative 1/2 and we got 1 from the top factors, you want to look at your inequality symbol and decide whether they're going to be equals or not equals. So in this case, it's greater than or equal to, so you're going to keep them as equal signs. If you did not have the line under the inequality, then you would turn them into not equals. So you're going to make your number line to start. Put your x's in order from least to greatest. So we've got negative 1 is the smallest, and we have a not equals symbol on that. The next number is negative 1/2, and that is equals, so it's going to be a filled in endpoint. Your next number is 0, and that is not equal, so an open endpoint. Your next number is positive 1. So here we see it's equals, but it's also not equal. You have to go with the not equal because that would create a 0 in your denominator, and you can't allow that to ever happen. So open circle for that. Then you're going to make your little chart so that you can figure out in each section whether the quadratic is going to be positive or negative. We're looking for positive because it's greater than or equal to 0. So we're going to put the factors in the first column, 2x plus 1 squared. Don't forget the square. Then your next factor is x minus 1. Your next factor is x, and then x squared minus 1. Then your columns, you're going to look at your number line that you just created and make intervals for them. The first interval would be negative infinity to negative 1. So that's the whole left side of the graph. Then your next interval is going to be negative 1 to 1/2. So this section. Your next interval is going to be negative 1/2 to 0. And your next interval is going to be 0 to 1. And your last interval is going to be 1 to infinity. Then you're going to pick numbers in each of those intervals, and you are going to test them in the factors. So if I plug in, say, negative 10, which is between negative infinity and negative 1, if I plug in negative 10, this is squared, so no matter what you get, you're going to get a positive. If I plug in negative 10 into the next one, I get a negative answer. Negative 10 into the third factor gives you a negative. Negative 10 in the next factor gives you a positive. Then we move on to the next column. I'm going to plug in, say, negative 0.8. If you plug in negative 0.8, you're going to go through and put something for that. So in your first factor, again, it's squared, so it's always going to be positive. If you want to go through and go ahead and put those in, it'll always be positive because it's squared. Your next factor, if I plug in negative 0.8, I get a negative, and then I'll get a negative for the third factor, and then I will get a negative for the next one. If I plug in positive, this would be like negative 0.2 is between those two numbers, so that would give me a negative, and a negative again. If I plug in positive 1/2, I would get a negative, a positive, and a negative. And then if I plug in, say, positive 10, I would get a positive, positive, positive. You then take those symbols and you multiply them all together. So a positive, and two negatives make a positive. A positive and three negatives make a negative. A positive and three negatives make a negative. Two positives and two negatives make a positive, and then four positives make a positive. So we were looking for where is it positive, because we're looking for greater than or equal to 0 from the original problem. So if I go through, that means anything with a positive, we're going to shade on the number line, and then anything with a negative should be left unshaded. So we're going to shade from negative infinity to -1 in the number line. Then we've got from 0 to 1 in the number line. Oh, and then that was positive as well. So then 1 to infinity, we're also going to shade. So then we're going to write our answer looking at the number line that we just made. So we'd say our x's are solutions if they are in the interval negative infinity to -1. You put parentheses on -1 because it's an open circle on your number line. You put your union symbol. You see 1/2 is the only point that is shaded, so you're going to put braces on that to show that it's just a single point. Then you put your union symbol. Then you have from 0 to 1, but you have to stop at 1, put parentheses on those because they both have open circles. And then you start again at 1 to go to infinity. So you would do union 1 to infinity. And so this would be your solution set.